Hello, today we're going to talk about how to determine if a relationship is nonlinear. So at this point, we've done linear, now we're going to look at nonlinear. So let's talk about nonlinear functions and what they look like. So from a table, if you were to determine if it's nonlinear, you would look for you'd still look for the change in y over the change in x, but they would not be equal to each other. In a graph, they would not be straight, so they might be curvy like that, or maybe they look like a upside down U, or maybe they look like a U. Anything that's not a straight line would be nonlinear. Maybe they look like something like that increases. Then from an equation, they would have exponents as with their variables. So you might have like y equals x squared, and that makes it nonlinear. Or maybe you have y equals 4 to the x. That makes it nonlinear. So any exponent that has a that's a variable, or any variables that have exponents, would make the equation turn and make it nonlinear. So looky here. We have which functions appear to be nonlinear. So which ones look like they're not lines? Well, that should be pretty easy. If you look at the red one, it's curved, so that's nonlinear. And this dark blue one here in the middle starts at the bottom and curves up. It doesn't go straight up. That's nonlinear. But if I look at this last one, it's pretty straight. So that one is going to be linear. All right, looking at equations, again, determine which function is nonlinear. So if I look at the first one, I have y equals 4x to the third minus 7. If you notice, the x has a variable, or has an exponent of 3, so that one is nonlinear. If you look at the second one, I would go ahead and simplify it just to be sure, if it were me. So I have 8x minus 4, no exponents, no variables as exponents, so that's linear. Now, from a table, we said that the change in y over the change in x has to be unequal. So if I look, I'm just going to look at my y first. So I go from 10 to 7, which is minus 3, and then 4 to 2 is positive 2. And then 7 to 4 is minus 3 again. 4 to 6 is positive 2. And 4 to 1 is minus 3 again. And 6 to 8 is positive 2. So these are all equal, so this is linear. Remember, you're looking for nonlinear. So let's try this one. The change in y over the change in x. We're looking for it to not be equal. So 1 to 8, that's a change of positive 7. And then 1 to 2 is a change of positive 1. Then 8 to 27 is a change of positive 19. And 2 to 3 is a change of positive 1. Those are not equal, so this one's nonlinear. Okay, now I want you to pause the video, answer these questions, and then play it when you're ready to check your work. So in letter A, we have y equals 17 minus 4x. Again, we have an exponent as a variable, so that one is nonlinear. The bottom one is linear. It reduces to y equals 4 plus 2x plus 14, which is y equals 18 plus 2x, and that's linear. If I look at the tables, again, we're doing the change in y over the change in x. So 3 to 2 is positive 2, and 3 to 6 is positive 3. 5 to 7 is positive 2. 6 to 9 is positive 3. Those are equal. And 7 to 10 is positive 3. 9 to 12 is positive 3. Uh-oh, so those are not equal. That's why we check all of them, because there could be a ringer in it. So this one is non-linear. Don't just assume that since the first two are, it's all good. Looking at the next one, your change in y, negative 2 to 1 is positive 3, and your change in x is 6 to 7 is positive 1. Then 1 to 4 is positive 3, 7 to 8 is positive 1, 4 to 7 is positive 3, and 8 to 9 is positive 1. So that's linear. Those are all equal to each other. Okay, so now you should be looking at the paper that has the situation, the equation, the graph, and the table. So decide if the function described is linear or nonlinear. So we're looking to see what is it. That's our goal. A single cell divides to form two cells after 1 minute. All cells formed after this also divide in two every minute. A function relates time in minutes to total number of cells. So we're comparing the time to the number of cells. So you should copy this down. Ooh, there we go. Into your situation. So go ahead and copy those words. You can pause the video if you want. So our independent variable is time, and our dependent is the number of cells. So if I have 0 time lapse, I have 1 cell. And if I have 1 minute, then that cell, if you can think of that cell, is breaking into 2. So now I have 2 cells. And after 2 minutes, the next minute, those cells break apart into 2. So now I have 4 cells. And then in 3 minutes, those cells break apart again. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 cells. So if you look at your graph, the time goes across the bottom because that's my independent variable. And I'm going to count those by ones. And my number of cells, I'm going to count by ones also. So if I look, I have 0 and then 1 cell, 1 and then 2, 2 and then 2, 4, 3 and 2, 4, 6, 8. And if we continued it again, if I had 4 minutes, I would have 16 cells. So 4, 8, 10, 12, 14, 16. So you can see this is definitely not a linear function. It's growing very quickly. So when things grow that quickly, here's a little hint. It's an exponential function. When something grows or decreases very quickly, we say it grows exponentially. So there's definitely an exponent in here. We have to find out what it is. So what is happening to my time to get the number of cells? So what's happening to 0 to get 1, 1 to get 2, 2 to get 4, and 3 to get 8? Well, if you look, it's timesing by 2 each time. That's your hint. So if I'm timesing it by 2 once, I get 2. And if I times it by 2 twice, I get 4. And if I times it by 2 3 times, I get 8. So my number of cells, say my y value, is going to be the 2 to the x exponent. So 2 to the 0 exponent would give me 1, 2 to the first exponent would give me 2, to the second would give me 4, etc. So that's my equation. We would never expect you to come up with that on your own at this point. Okay, now copy down the next situation onto your notebook paper, and you can pause the video while you do that. So John mows lawns. He charges his customers $15 per hour. A function relates the number of hours, so that's my input, John works, to the amount he earns. Is the function nonlinear? So we're going to talk about the number of hours to the amount of money he earns. So we're going to say amount. So if he works 0 hours, he gets $0. And if he works 1 hour, he gets $15. And if he works 2 hours, he gets $30. And 3 hours is $45. This is pretty simple, makes sense. So let's go ahead and graph it. My graph doesn't want to work today. So my bottom, my bottom is going to be my hours worked. And then my vertical is going to be the amount of money that I get. So if I have 0 hours, I get $0. And then I'm just going to count, my hours by ones because I have so many. And then I'm going to count my amount by fives. So 1, I get $5, $10, $15. And then 2 hours, I get 60, 5, 10, 15, 20, 25, 30, or I'm sorry, 30. And 3 hours, I get 45. So 5, 10, 15, 20, 25, 30, 35, 40, 45. And I could have gone again. So if I did 4 hours, I would have got 60, 45, 50, 55, 60. And because you can work part of an hour, this could be a straight line. So it's not discrete. So if I look, according to my graph, it should be linear. So I should have a nice, easy equation. So if I look at it, what am I doing to my hours to get my amount? Well, I'm taking my number of hours, my amount equals the number of hours times 15. That's my equation. So this is linear. Make sure that you have these notes complete and that you do glue them into your interactive notebook.